Okay, so we are looking at this one. So what's the answer? What answer do you?
That one is true.
True?
True.
Let me see.
One of this.
Okay. Any other suggestion for the answer? You know, programming is logical reasoning. No suggestion? Okay, so let's.
Why? Why?
Why?
Why?
Good,
Why?
good question.
This was the way I understood.
Is it?
False or not true? Not true is false. False
Not,
or
not true is
false.
false. So let me help you to get it. Put
Okay.
false. Put false here.
Okay. That's what I'm saying. I put false there.
Okay, false or
So
false?
false or false is false. False and true is false. What was I
So,
mistaken
so,
this
so
again?
you see that is correct.
Yeah, it's
Okay.
correct.
Yeah.
What is-
Yeah. Now, you see, not is always done first, actually. Hmm? Not is
Yes.
done first, followed by and, followed by or. But all the examples we have been seeing, if you just take it straight from left to right, you actually get it. Okay, so false
Yeah. Done.
or false is false and true is false. Okay, but actually the real thing is to do the not first, then do the and then do the or. Okay, all right. So now let's take another other types of example where we use what do you call it now? Where we use numbers. Okay, so let me test you with that. Again, suppose we say x. What is x? X is 20. X modulus y is 10, right? Modulus y divided by 2 minus 2. Okay, try your hands on this. You can use biro and paper to solve it there so that you can get the answer correctly.
What is this sign? That one that looks like division.
That is the integer division. You remember integer division?
Integer.
The one we call floor operator. Let me show you. We did it on the we did it in the last class. This one.
Okay. Division. How did we how did we use
For example, if x is 3, for example, and y is 2, the answer will be it will be 1. If x is, let's say, okay, let me say if x is 5 and y is 2. Okay, normally when you say x divided by, when you say 5 divided by 2, you get 2.5, isn't it? Normally, right? In normal, ordinary division. Okay, but
yes?
in integer division like this, the 0.5 is removed. It's just the whole number. So x divided by, if you do the interdivision of x divided by, rather 5 divided by 2, you are going to get 2, just 2, not 2.5, just 2. The whole, anything after the point is cut off.
Okay, just the number.
Just the whole number, yes.
Okay. Okay. All right. Let's test this.
Okay, this one is okay, not equal. Okay, that's right. Not equal to 1. Are we there?
That's how I was looking at it.
Oh, let me.
Okay,
All right. So if you look at this is already false, right? Uh, this is already false. X integer division Y. I think X was 20, right? 20 divided by 10 is 2. 2 less than or equals 1. 2 is not less than or equals 1 now. Oh, I didn't redefine X and Y. Oh, sorry for that. So I have to define X and Y. I thought we had already defined X and Y. And then Y is 10. Is false. The answer is false. Okay. Why? Like I was explaining to you, this is already false now because you can see and um, I'm starting from this side because this side is simpler, right? Once there's any false, if one out of these two is false, then the answer must be false. Because we've already seen that for operation, whenever there's any false in it at all, the answer is always false. Okay, so here, this gives 2, right? 20 divided by 10 is 2. Is 2 less than or equals 1? No, so this is false. So what you have on the right-hand side of the AND operator here is false. So whether this side is true or false, the answer must end up being false. Is that understood? Do we understand that? Hello?
Yes, I understand.
Yeah, but nevertheless, let me explain what happens on this side, okay? Now, but whatever we get here, whether it's true or false, the answer will be false because this side is already false. And we are dealing with AND. Okay, but let me explain what happens here, what you do here. Now, when you are solving this kind of problem, you know that first you have to attend to the brackets, don't you? Okay, you know that, right?
Yes, sir. Yes,
Yeah,
sir.
so you first of all deal with what is in this bracket. Y divided by 2, y divided by 2 is 5, because y is 10.
Plus 5.
Y divided by 2
2.
is 5. 5 minus 2 is 3, right?
Correct.
Yeah, 3. So this is x is 20. 20 modulus 3. 20 modulus 3 is what? That's like 20 divided by 3. What's the remainder? Is it not 2? Is it not 2? 20 divided by 3 gives you 20 divided by 3 gives you what do you get? Is it not 6? 6 times 3 is 18. 6 times 3 is 18 now. It's 18. So this is 2. X modulus 3 is 2. Hope you know how I got 2.
Yes.
Because if you divide 20 by 3, you get 3 remainder 2. And that remainder is the modulus. Okay? So we have 2. And then 2 not equals 1 is what? 2 not equals 1 is 2 not equals 1 is true, right?
2 not equals 1.
Yeah, because 2 is not equals 1.
Language.
Hmm?
The language.
Yeah. 2 not equals 1. That's what is here. Do you get what what I'm saying? Now you have already solved all this now. You have solved all.
Yes.
Hmm? You have solved this now. Let me do it here so that you see what I'm talking about. Uh, can you see you are getting 2? Hmm?
Yes.
That's 2. That's what I was telling you just now. Okay. You are getting 2 from all this. From all,
Yes.
what did I, yeah, from all this. You are getting 2. 2 not equals 1. Is 2 not equals 1? It's true now, isn't it?
Sure. Yes.
It's true now. 2 is not equals 1.
Yes.
Yeah. Not equals 1. Okay, it's true. 2 is because 2 is not equals 1, right? Then when you now apply not to that, what do you get? False, isn't it? You get false, false and false. We got false on this side before, right? Are we still on the same
Yes.
page?
Yes. Yes.
Yeah, we got false on this side before. So false and false gives what? False and false gives false. So the answer is false. This one is a very big false because both sides are even false. Okay. I hope it's clear.
It's there.
Yeah.
It's there.
Okay. It's just to know the order, okay, in which to do this computation. All right. So this is how the truth table for all works. Okay. Now, when you are when you are applying these logical operators and relational operators in conditional statements, this thorough understanding of this will help you, okay? To help you. Because sometimes you see some people when in a position where they need to use and, they'll be using or, or vice versa because they don't thoroughly understand these things. Okay. So that's it. Maybe as we move on, we take several examples, you get very used to these things. So that does it for operators. Any questions? Because it's getting late, so that you guys can go and sleep. Or you want to watch late night movie. It's all still there.
I want to watch you that movie.
Obi, are you
So,
still there?
um, um,
You are here. Okay.
hey,
I thought you've gone to watch late night movie.
Yes, that's what you like to.
it's catching me up.
You said?
I said I'm feeling sleepy. Not listening
Yes,
to me.
yes, I know, I know. That's why I said we are wrapping up now. Okay.
Mm.
Okay. So you are not watching late night movie. You want to go and sleep.
Yes, sir.
Okay, that's good. So
That's what she say.
see you guys tomorrow.
Is she correct? Hey.